So, as a continuation on this series we've been doing on just electric bike education and these various topics, today we're going to be talking about motors, more specifically electric bike motors. And we're going to talk about some of the different terminology used, the different types of electric bike motors, and some of the common questions that come up. So, to start out, I'd like to answer this question. What is an electric bike motor and what does it do? To have an electric bike, you have many different components that make up this bicycle. First, you start with all the basic components you have as a traditional bicycle. But as far as the motor system, there's kind of a couple of main components. You have the battery, which is providing the power to the motor. You have the controller, which effectively regulates the power going into the motor. And you have the motor, which actually drives the bike. Now, I'm going to keep most of this discussion today pretty simple and general, but there's plenty of videos out there if you want to learn more about electric motors and how they work and all the finer details of that. So you have these three main components. You have the battery, the controller, and the motor, and usually you have some sort of interface that you interact with. It could be a throttle on some of the more basic electric bikes, or some of the more advanced ones, they have some different sensors that you interact with that tell the controller that you want power, how much power you might want. In telling the controller that, the controller basically pulls power from the battery and pushes it into the motor. And the more power that the controller pulls from the battery and pushes into the motor, the more power you're going to experience. The faster you're going to go, the faster you're going to accelerate, that sort of thing. So that's in basic terms how that motor system works. The motor can be placed in a variety of different places on the bicycle. We'll kind of get into a lot of that stuff as we get down this list. So another topic I'd like to cover more specifically related to electric bike motors is what are watts, amps, newton meters, etc. This one comes up a lot, and I think it's often misrepresented, this information. A lot of times most people really focus on how many watts something is, but I don't think that that's always necessarily the best representation of how powerful a motor is. Although in real scientific terms, a watt is a measure of power. So, to keep it simple, right, watt is a measure of power, and it's for electric bike motor, you have ratings of what the motor is really intended to handle. You have like your nominal power or continuous power, and that's really what the motor is intended to operate at a continuous rate without having any real issues with heat or that sort of thing. Then you have your peak power, and that's really what the motor can handle at its top power, and it generally can only handle that for a shorter period of time. It can't continually operate at that power. So different companies will publish different information in relation to this. Some will say this is what our nominal power is, but actually their peak power might be much higher, and some of them can operate at that peak power for an extended period of time. Some of them might be a little bit more boastful about these numbers and say, they actually publish what the peak power is. And that can be a little bit misleading because if you're comparing, the two, could be a bit confusing there. Another thing good to be mindful of is there aren't really much of any independent testing sources for this sort of data. So the numbers are kind of a little bit all over the map. And a lot of companies will like you to believe that their motor is much more powerful because they list it as 500 watts or 750 watts, but all these things are not necessarily created equally. But I'll go more into just the specific terminology. The next one I'd like to talk about is amps, because this is pretty important. The battery, you have voltage, which if you want to learn more about batteries, we did a little bit of a primer on that, and you could learn more on that topic. But the battery, you have voltage, and then actually the rate at which that voltage is flowing is called the amps. If you wanted to actually get the watts of a motor, or like the output the battery is putting to the motor, you would take the voltage and you multiply it by the amps, and that's how you end up getting the watts. So for the most part, you'll see controllers are regulating something for like 10 amps, 15 amps, maybe 20 amps at like the really higher peak power and that sort of thing. So that's a good kind of indicator of how that power is flowing. So that's kind of what an amp is, more or less. Now, this is not to be confused with amp hours. This is something commonly used for batteries, and that's just basically how long a battery can be run discharging 1 amp. So if something was 10 amp hours, that means that if you were pulling 10 amps from it, it would take 1 hour for that battery to fully discharge. If you had a 20 amp hour battery and it was running at 10 amps, it would take 2 hours to fully discharge that battery, running it consistently at 10 amps. But you're generally not going to consistently run at that power. It really all depends on the specific bicycle and how you're using it. So we talked about power, which is one of the more common ways that people are rating motors and electric bikes and that sort of thing. But I think actually it's a little bit misleading, because I think of power in a lot of ways almost like fuel mileage on a car. If you actually look at it, what's really more important is like how powerful it is, or like how it can propel you, if you will. That I look at more from the perspective of torque. I look at the measurement of torque as more realistically what the electric motor can actually do. Torque is a measurement of just the force. It's the turning force. And if you think about it, for an electric motor, this is really important, because this is actually what's going to help you get up a hill and that sort of thing. Torque is going to be measured in Newton meters. Commonly, it's written as like a capital N and a lowercase m. So you can see this number vary all over the place, but on the high numbers, it's probably somewhere in the 80 or so Newton meters. You can see things as low as 20, 30 Newton meters. Now, this will also vary depending on where the motor is placed and like how you experience that torque, but I find that this is a really important thing to think about when you really want the electric motor to help you get up a hill easier, to start out faster, and that sort of thing. The torque is really going to help significantly in this specific instance. I think that that's really like what most people are looking to an electric motor for, right? You just want that assistance in those more troubling times, and some of those things are, going up a large hill, starting out, carrying a heavy load. This is where torque is really going to come into play. Now, we could speak a lot deeper on a lot of this terminology and that sort of thing, but I want to try to keep this pretty simple. If you guys want to see maybe another video covered on this topic, if you have additional questions, maybe you can leave them in the comments below, and we'll try to address that in the future. So the next question I'd like to cover are, what are the different types of electric motors? Now, this can be answered in a couple different ways, but today I'm just going to focus more specifically on the different placements of the motors and probably the two more common types of motors that we've seen historically. Now, on the specific types of motors, you'll generally see what's called a direct drive motor, which had been more common historically, but it's becoming less and less common these days. The direct drive motor is a little bit simpler in its makeup, but it can be usually a little bit heavier. It doesn't have some of the mechanical advantage of this other type of motor, which is a geared motor. This motor we're seeing to be most common these days. The benefit of a geared motor is you're able to use the mechanical advantage of gears. Now, electric motors generally like to spin kind of fast, so adding gears to that direct drive motor brings a big benefit, allowing the motor to spin faster but change the ratio of what the actual output is. Now, the electric bike motor can be placed in a variety of different places. One, you'll see occasionally, maybe not so common these days, but it had been more common in the past, more so for like these add-on kits and that sort of thing, is a front wheel hub motor. And basically what that means is you have the motor inside of the hub of the wheel, and it's placed inside the forks of the bike. Now, this motor placement style had historically been pretty popular, but there's some downsides which I think probably encourage some of the rise of these different motor systems which are on the market today. One of the main ones is that it can be more likely to lose traction with the front wheel of the bike if you don't have enough weight on there, particularly if you're going up a hill or something like that. You might have even noticed when you're riding a non-electric bike, if you're riding up a hill, you might end up feeling like your front wheel is lifting off the ground a little bit. Now, if you have an electric motor providing power there, you could end up in a situation that, this is like losing traction. It could actually be dangerous at times. So that's not something that we generally recommend, and it's something to consider if you are looking at a bike with this type of motor system on it. The next motor placement will be in the rear wheel. So it's like a rear hub motor. This has been very popular, probably one of the most popular motor system placements in history. And this provides a benefit because one, you have more weight in the back, so it just kind of can push you so you don't have that traction issue you might have with the front hub motor, but it can produce some challenges in that it makes the back of the bike a little bit heavier, especially if you have a battery on the rear rack, which historically you have seen that a little bit, maybe not so much these days, but that has been a thing. So having all that weight, it can make the steering a little bit weird on the bike and that sort of thing. It's also inside of the wheel, so it can potentially put more stress on the wheel. So for us as a shop, we don't actually work with those types of motor systems. Historically we have, but we really prefer this last type, which is a center drive motor. Now this motor is placed directly where the cranks are, and from my perspective there's many benefits to putting the motor here. One of the big ones is that it's actually using the bike's gears as a mechanical advantage. So this is the only one where you actually have somewhat of a transmission, if you will. So it allows you to actually be a lot more efficient. It allows the bike to potentially be a little bit lighter if you want to have a decent amount of output. So you'll find this on higher performance bikes, generally speaking, particularly like mountain bikes and that sort of thing, because it allows you to have still a lightweight wheel which can perform really well, but still delivering a good amount of power, especially when you shift through those gears and that sort of thing. This is really helpful, especially if you're climbing large hills. Now you think about it, you're going up a large hill, you shift into a low gear, and you have that mechanical advantage. So you're not putting so much stress on the motor, you're not putting so much stress on yourself. You'll also find when these motors are paired with good sensors, they'll produce a very seamless ride experience because you're pedaling with the motor, it's providing power at the same place. So you kind of just feel a little bit stronger than you normally are, and it produces a really natural and predictable result. I prefer this because it makes it such that you don't really have to think too much about your riding or the motor or how it's going to react, and I think that this is really important. We'll talk a bit more about the sensors in just a moment, but I just wanted to give you some perspective on that. There can be some disadvantages in comparing this and the other more common motor system like the hub motor. Now, a center drive motor could potentially put more wear on your drivetrain, your gears, and that sort of thing because you are delivering more power there. So some people will say it's a good idea to get a hub motor because you're going to put less stress on those gears and that sort of thing. So there's always a bit of a trade-off. Some of the manufacturers have been solving this with offering different drivetrain options or finding other ways to put less stress on the drivetrain. The main manufacturer we work with specifically is Bosch, and they have a technology called shift sensing. And the idea basically is that they can sense when you're shifting the gears. This is when you potentially put the most amount of stress on your drivetrain and chain and actually lets off the power during that time, which is kind of a split second, and it's pretty amazing that they're able to do that, but it really helps to preserve the life of the drivetrain. But we're finding more and more common that a lot of the manufacturers are actually going to internally geared hubs where this actually becomes a lot less of a factor because all the gears are inside and you're not having that variation in the chain line and that sort of thing. But both of them work really well, and it's definitely something to consider. And the next question is, what different types of power delivery are there? Now, there's a couple different types. The first one is probably the most rudimentary and the simplest in its form, and it's a throttle-activated system. And basically, it's just as you would find on a scooter or a motorcycle, and you just twist the throttle, or you can push the throttle in some cases, and it just delivers power. And it can deliver power generally proportionate to how much you twist it or how much you push the lever or whatever the case may be. That's really simple, and that type has been around for a very long time. But what happened over time is people found that, oh yeah, when I'm riding, I don't feel like I want to be like worrying about this. So there was kind of this evolution that happened over time, and there was introduced what's called pedal assist. Pedal assist basically is this other type, and becoming probably the more popular type these days, particularly in our shop. That's really all that we do is pedal assist. Basically, this technology, what it is it senses that you're pedaling and it delivers power proportionate to your pedaling. Now, in early days of pedal assist, it was pretty rudimentary. You had what's called a cadence sensor, and the sensor just basically senses how fast you're pedaling. The challenge is that it would produce somewhat unpredictable results at times. So the engineers that were working on this problem, I guess they were trying to find different ways to deliver power a little bit more predictably. And they introduced an additional sensor. And this sensor is called a torque sensor. The torque sensor basically, it senses how hard you're pedaling. So now you have how fast you're pedaling and how hard you're pedaling. With that data, you can produce a lot better result. But these days, we're seeing it more common that there's actually 3 sensors being used, and the third one is the speed sensor, and that's basically sensing how fast the bike is going overall. And based on all this information, you're able to provide a pretty seamless result, or at least these manufacturers are. I don't know that I can figure out a way to do that. I'm not an engineer, but from my experience, the manufacturer that we choose and feel like they really do the best job at this is Bosch. They're using these 3 sensors, and they're taking 1,000 senses per second, which is pretty amazing. When you ride the bike with this motor system on it, it really is very predictable. It kind of gives you the power exactly when you want it, exactly how you want it, and you don't really have to think about that. So that makes a safer experience. It makes a more enjoyable experience from my perspective. And what I really like about this is it encourages you to pedal. You have this throttle system, which is still used today, and some people it makes sense. And from my perspective, I think that most people don't necessarily need it, but there are some people that do need this. And we actually made this whole video about throttle versus pedal assist, and you might want to check that out if you want to go a little bit deeper into this topic. But basically, we have the throttle, the pedal assist, and some bikes will have both. What I found is most of the cheaper bikes have throttle on them, like they're not as good quality, because it's kind of a simple thing to do. It really doesn't take any extreme effort to figure out how to put a throttle on the bike. But pedal assist, at least advanced pedal assist, it's not necessarily the easiest thing to achieve, and that's what, from our perspective, we try to just work with the best manufacturers in this because you really want to produce that really seamless experience. But as I said, some will have both, but it's really up to you. I recommend testing both and see what you like. And this next question comes up quite a bit, and it might seem obvious to some, but for many it's not. Can I ride my e-bike without power? The answer is yes. So in simple terms, that's the answer. I will say that an electric bike can tend to be a little bit heavier than a non-electric bike, so you might find that it's not as easy to ride without power, and you might want to consider getting a bike that's not terribly heavy if you do consider that you want to ride it often without power. There are some other factors that come into play. I was talking about those different types of motors out there. A direct drive motor, more specifically, is a motor that can produce a little bit more resistance when pedaling without power. So if you do want to ride a bike without power or do it often, I would recommend going with a electric bike with a geared motor. This is also a big focus these days for a lot of the electric motor manufacturers to make them easier and easier to pedal without power, just to make them as natural as possible. Many of the manufacturers have been focusing on ways to improve the experience there, because I think a lot of people are buying these electric bikes for exercise, and there might be some scenarios where it makes sense just to ride it without power. Obviously, there's also that scenario where if your electric battery dies and you just want to get home or whatever the case may be, you don't want to feel like you're pulling a really heavy weight there. So now another question that comes up all the time is, how many watts do I need? And in our shop, actually, most of the bikes that we sell are rated at 250 or sometimes 350 watts, but a lot of manufacturers will tell you that you need 500 watts or 750 watts or 1,000 watts, which is actually illegal in most places. I think that it's actually a little bit more confusing, or maybe not as simple as some will make you believe. As I mentioned before, watts is not always the best measure of power in relation to electric bike motor, especially the way that manufacturers publish that information. Many of the motors that we offer that might be rated at 250 watts, their peak power is well over 600 watts, some of them up to close to 800 watts. So although it has this lower nominal rating, it has plenty of peak power and it's got plenty of torque. So from my perspective, I think it's much better to look at torque than it is to look at watts, but many manufacturers will want you to focus on watts because it's an easy way for them to communicate that, oh, we have more power, but it's really, there's nobody out there independently testing this or anything like that. So, but don't take my word for it. I would really recommend testing one. I mean, if you test a bike with a 250 watt Bosch CX motor against many other manufacturers' 500 or 750 watt motors, you'll notice a significant difference. And for the most part, you'll probably notice that the Bosch motor is way more powerful. So don't be fooled by the numbers that a lot of these manufacturers put out there. Now, another important question in relation to electric bike motors is how fast can they go? Now, what a motor is actually capable of and what it actually is allowed to do, those things can vary greatly, but generally speaking, the motors that we'll find here in the US are going to be regulated to 20 miles an hour, or some will go 28 miles an hour. In Europe, you might find it more common that you'll have motors that go like 15.5 miles an hour or 25 kilometers per hour, or in some cases 28 miles an hour with the specific speed pedelec bike. This is 45 kilometers per hour. And there might be some regulations in like where you can use these different bikes and what's required for their use. For example, some of the faster bikes you might be required to wear a helmet. Maybe you might be required to have a license plate, like in Europe, for example, not necessarily in the US. But as I mentioned, it could be the case that the motor is capable of going much faster, and sometimes people will actually build electric bikes that can go faster than those things, but the actual regulations in the US and in Europe and most other places in the world will restrict the speeds, and so the manufacturers usually build their controllers to restrict the speeds to that specific regulation. And although it can certainly be thrilling to go beyond those speed limits, I would definitely caution you about trying to do that. One, it's not quite as safe, and two, you might be breaking some laws and might get yourself in trouble and potentially put a bad name on the electric bike industry that's really just getting its start, and we don't really need people out there kind of messing that up from my perspective. Well, I try to cover the most common questions asked, but if you have your own questions, you want to leave them in the comments, we'll do our best to answer them and perhaps add them into a future video. I think we should probably make this like a part 1, and we'll do like a part 2 afterwards, including some of those questions. Well, I hope you guys enjoyed this, and I look forward to seeing you in a future video. Well, see you soon.